Today is a beautiful day for science. Currently, we're going to take a closer look at the M-3.96 that occurred this morning. And it had two coronal mass ejections, one that went to the east and the other one that gave us very nearly a full halo. It's a partial halo. But we're going to take a closer look at that event as soon as I can figure out where the button is. All right. Here we are. And hello. Oh, I hear me. There we go. Fix that. All right. Yeah, I had my video backed up looking at something else, and I realized I was not on the sun. I'm always analyzing something and double checking work and such. Anyways, here we are. And that is not it. Let's go ahead and go to here. There. Beautiful. Alright, we're going to move you for now. And I'm going to bring you in. Oh yeah. Alright, so here is that particular event in question. This is the M3.96 solar flare. And what's beautiful about this is you can see two CMEs that occur. One very rapid and one post the flare itself. So we have the primary significant CME here. This will be an ICME towards the east. It is not going to be impacting Earth. It is fine, but very beautiful. And then post that, we see another CME that occurs from the upper portion. Here, let's see. Let's take this a little bit slower. Take you down to here. I got lots of imagery here so we can get a good grasp on this. So here goes that. There's the flare, and there's that CME right here. So southern push. Absolutely. Okay, looking at on 131. There goes that, and here comes this one here. It looks like there might have been a third small eruption as well from our little hangout over here, but I'm not sure that became an ICME. Okay, so we have this one, and then this, and this. So this is just a significant flaring. Let's take a look at that shock wave. All right, there's that. So yeah, primary, secondary. So yeah, we have two CMEs that have occurred. And there's a small eruption here, but that does not become anything. That stays localized. And it is the secondary CME right there that we are looking at that will be impacting Earth. This is not all that significant from the looks of it. It doesn't appear to be that much. Definitely moving a lot slower than the predecessor. Let's get a little bit closer. Get a good view on the secondary eruption. Right there. It's not that significant. That primaries where the meat of the CME activity went. It's a large area, so it's going to be it's not going to be nothing. It's not going to just blow over, but it's not with the significant cloud of plasma that you would see sometimes from these eruptions. I'm wondering how much upper atmosphere in the corona and above the corona plasma might have been involved. Ooh, look at that fast movement. Yep. So, yeah, and there's another, oh, yeah, that's where it came down. Okay, so here we are. I can see it clearly now. So we have the eruption here. This is where the CME is coming from. And we can actually see some of that plasma post that secondary CME coming in over here, right there. So some of that plasma coming back in right there. And then we have flaring ensue because of that introduced plasma to the already volatile region. All right. Very beautiful. Yeah. All right. So yeah, it's not going to be overly significant. I would say it's. I mean, look, this is looking the upper corona with that 335. So I guess it's a good view of that over-encompassing shock wave that occurred there. It's not extremely massive, and we did not get a proton event, which is significant because that's actually what I was looking for. And this is the very reason right here. If you see the amount of plasma motion that occurs in this leading negative area, that's kind of odd for 3296. It has plasma that overlaps that umbra, showing that there was a significant amount of plasma motion. But because it didn't actually conclude to more of that plasma being injected externally, I think that means a lot of that material that would have otherwise been more projected towards the Earth actually got drawn back in due to the strong electromagnetivity on 3293, which is in front of it. And it's become more volatile because it's had a growth of energy from within that region, having that positive umbra form as it rotated in the view, suddenly escalating its potential and energy and activity from that low to mid C tier activity to, as we saw, even being part of this M class here. But this M class is between two regions, technically three. There's a lot of intermingling here, and it's because 3296 is the instigator. And that's what we see here. All right. Well, that basically covers it. So, once again, because I believe that we can get a good view of this, we're now better understanding, looking at the coronal mass ejection itself. Let's take a look at SOHO and stereo ahead. All right. And I need you. There you are. All right. Beautiful. All right. So, in looking at this, what we can see, let's go to one of the C2 images a little closer so we start seeing where it starts to begin to spread, and we is around image 58, I believe. All right, so we have that northern activity occurring. This right here is that those plasma at the caps, northern cap that's been dancing, doing a little bit of a ballet. We're going to have our significant eruption. Right there. Now this is the primary, or not primary, the initial eruption. This is the first eruption. What happens is we can see that flaring begins. A lot of instability is beginning, and apparently a lot of that energy had built up and it just completely expelled this plasma from south of 32 296. So this is the first eruption. And about here, yeah, you can really start to see the distinct second eruption. There. So you can see the separation of them. So we have right here, if you look at this spot right here, the initial burst, and that comes across over here. And that actually comes down, I believe, about right there. But it's going to start to spread, and we'll see it actually reach, not that way, about there. There we go. Give or take. So let's continue. And we can see that right there. We can start seeing the eruption reaching out to this point over here. Very nicely. It's a little faint, very difficult to see with the other activity that's occurring. A lot of those bright streamers reaching down to the south, making it difficult to differentiate between the streamers and the CME. And then there's also a CME that does occur on the south as well. And that's actually where we stop at right now with Soho. It's most updated. However, let's take a look at C3. And again. So again, we have that northern push right there. Very beautiful solar cap dance. And we're going to get our expedient, powerful eruption of CME material. Plasma coming out there. There it is. Right there. And then you can see that secondary. Right there. So we have two eruptions. One's right there. And the other one's right there. And it's just now starting to show on the other side. Right there. And there we are. So a partial halo. It is projected towards Earth. It is a coronal mass ejection. It is not significant. This is one that I would say would most likely, from what I can see and the other data, I mean, it's not highlighting itself abundantly above the other activity that's ongoing, so it makes it very difficult to see. It's kind of faint. I mean, we're looking at maybe a G2 at best or most severe, I should say, for this event. It's not moving exceptionally fast either, as we can see. But to get a good measurement on that speed is going to be very difficult with that other interference. However, we do have one other view that I think it shows a little bit better, and that will give us some better input. So I'll use this one to do the measurement. Of course, the northern cap. Now we have that burst. This is the initial CME. And then there's the secondary. And we can see clearly here it reaches to this point here. A little more difficult to see the separation upon the actual where they overlap on stereo ahead's difference imagery. So using the points where there's a separation independent of eruptions here makes it easier to do so. And as you can see, once again, partial eruption, or partial halo rather. What are you seeing stereo? Now that's something that's just happened. Let's take a closer look at that. So let's go to current. Hello. All right, let's take a look at 171. Actually, no, let's go to, first go to 304. 304, see if there's any noticeable plasma motion. Nothing exceedingly visible. All right, let's take a look at GOES rather. 195, is it? How about there we go. Yeah, 195. Give us a good view of that corona to see if there's any shock waves occurring. And what do we have happening? So that's a backside event. Definitely backside. Not seeing any major expelling of plasma. Not seeing anything that stands out. No major shock waves in the past 3 hours. We have some plasma dancing on the rim. All right, so yeah, I would say that we have backside activity that gave us a beautiful view as well here. So let's take a look at that again on stereo ahead. Once again, another prime example on why we really should have an additional perspective of the solar activity as opposed to just the point of view from the Earth. Very limited run on understanding and following the plasma and activity. All right, so first the north cap, then we have the primary eruption, then we have the secondary eruption, and recently we have what appears to be two separate eruptions occurring on the backside. And let's go back to that, shall we? And there we are. So yeah, we have two separate eruptions. This is definitely not a single eruption. We have this guy right here. Hello. And then we have this guy right here. Hello. All right. There we are. Oh, that's very exciting. So yeah, a lot going on in the sun right now. We have the dancing solar caps that finally erupted on the north. We have a dual CME event that occurred from 3296, 3293, and one of those, the smaller of the two, will be impacting Earth, probably with a small geomagnetic storm. It does appear to be more of that 48-hour. I'll do a better math projection here in a little bit, but it does appear to be like one of those 48-hour to maybe a little bit even slower CME projections. The event that happened post that is we have two interplanetary coronal mass ejections, ICMEs, that are heading to the northwest and the southeast, and neither is visible, so they're both on the backside of the sun. So, of course, not projected towards Earth. So that just happened as well. So, hey, a little bit more extra. All right. Love it. And let's take a look again at the event itself on high-resolution imagery, because we can. And this time, let's watch it in full motion here as opposed to slowing it down. Whoops. There we go. Yeah, perfect. All right. All right, now we're looking at it in just a little bit slower than what SDO compiles, but I have more imagery than SDO compiles in the videos they put out. So this is going to have about twice the imagery involved to get a little more of a seamless view of that activity. So this is all 8K imagery streamed together from SDO satellite. Very beautifully presented to us by SDO. Thank you very much. Love those guys. And here we have that M-3.9 solar flare with two CMEs, one projected behind Earth's orbit, no worry or concern for Earth, and that's the more impacting and more powerful one. And the lesser of the two CMEs, which is more of the plasma that was expelled with the flare. And this is going to be the one that's going to be a partial halo on our SOHO and stereo head, and it's expected that we will be seeing this event. And my preliminary assumption of the data would be approximately 48 to about 48 hours, plus or minus 6 hours post eruption, and it's not significant, so we may not even see G2 levels from it, depending on what else is going on. So G2, I would say, would be the max, based upon the amount of plasma involved, the speed and the force, and the overall projection. So there we go. That about covers it, and a little bit extra. I love it. Science is beautiful. So cheers and science on.